Welcome to Lesson 01 of CrowdSec Mastery. The lesson where we stop talking about why CrowdSec exists and start defining what it actually is. And the short answer is, it's three security tools fused into one daemon, an IPS, an IDS, and a WAF, driven by behavior-based detection rather than signatures. Over the next 4 sections, we'll unpack those layers, contrast behavior versus signatures, look at the leaky bucket algorithm under the hood, and walk a real SSH brute force from log line to ban. So by the end, you can explain CrowdSec to a colleague in 2 minutes flat. So let's name those 3 layers properly. An IPS, intrusion prevention system, blocks the bad guys. In CrowdSec, that's the bouncers, sitting at IP tables, NFE tables, or Cloudflare, dropping an SSH brute forcer at the firewall. An IDS, intrusion detection system, just sees them and tells you. That's CrowdSec's console and alerts API, feeding your SOC, your Slack, your on-call. And a WAF, web application firewall, filters HTTP requests for things like SQL injection or XSS. That's CrowdSec AppSec, with OWASP rules. Most shops buy 3 vendors for this. CrowdSec gives you one daemon, one config language, one community. Now the second thread running through this whole course. CrowdSec doesn't do signatures, it does behavior. Think of it this way. Your antivirus matches file hashes against a database of known bad. Fast, deterministic, 0 false positives on what it knows, and completely blind to anything new. CrowdSec, like failed to ban before it, flips the question. Instead of asking, have I seen this exact attack before, it asks, is this IP doing something a normal user wouldn't? Too many 401s, too many posts, too fast. That catches novel attacks for free, but it costs you tuning, and it's harder to explain to an auditor than we matched signature X. So how does CrowdSec actually decide that behavior is bad? With a beautifully simple data structure called a leaky bucket. Picture a bucket with a hole in the bottom. Every event, say a failed login, drops in as water from above and water continuously leaks out. One failed login every 30 minutes? The bucket leaks faster than it fills. Nothing happens. 3 in a minute? It's filling, but holding. 10 in 30 seconds? Overflow. And an overflow is what CrowdSec calls a decision. That's your ban. Every detection rule, what CrowdSec calls a scenario, is just a bucket with a different size and leak rate. Now zoom out from one bucket overflowing on one server and watch what happens across the network. Every CrowdSec instance runs the same 3-step loop. Step 1, local detection. Your scenario triggers, a decision is made, the IP gets banned for 4 hours on your box. Step 2, central curation. An anonymized signal goes up to the CrowdSec API, where it's cross-checked against reports from thousands of other instances, and noisy or low-quality reporters get filtered out. Step 3, global block list. Validated IPs flow back down to all 95,000+ instances every 4 hours. So an attacker burned on a server in Singapore at 1403 is on your firewall by 1803. That's herd immunity for servers. Let's bring it back down to one machine and watch the whole pipeline fire in real time. At T0, a failed SSH login lands in auth.log. Acquisition reads the line, the SSHD parser extracts the source IP, the user, and tags the event as a failed auth. The SSH-BF scenario is watching for 5 of those from the same IP inside 60 seconds. And at T+38, the 5th attempt tips the bucket. A decision is created and pushed to the local API. The bouncer pulls it 10 seconds later, and an iptables drop rule appears. 6 steps, 0 human intervention. And notice, nowhere did we match a signature. We matched a behavior. That decision we just created, let's follow what happens to it next, because it doesn't live forever. Every decision moves through 4 states. It's triggered the instant the bucket overflows, becomes active once LAPI stores it and bouncers start enforcing for the ban time, 4 hours by default. Then it expires when that timer runs out. kept around for roughly a week so you can audit it, and finally a garbage collection cycle deletes it from your local database. And if you ever need to peek mid-flight, CSCLI Decisions List shows you exactly where things stand, or you can delete an IP manually to cut a ban short. Now, here's the part that turns CrowdSec from interesting into genuinely productive. You almost never write parsers or scenarios yourself. The hub is a community marketplace where everything is already packaged. Collections bundle the parsers, scenarios, and configs for a specific service. One CSCLI command pulls down Linux essentials, Nginx, WordPress, and a WAF with 1,500 OWASP rules, 12 parsers, and 26 scenarios installed and ready. Lesson 9 goes deep on this. For now, just remember, don't reinvent detection, install it. With all that capability, it's just as important to draw the boundaries. CrowdSec isn't an antivirus, it watches behavior, not files, so ClamAV still has a job. It's not a DDoS mitigator. If your pipe is saturated, you need Cloudflare or AWS Shield upstream. It's not a CM for long-term log retention, reach for Wazoo or Splunk there. It's not a network IDS either because it reads logs, not packets, which means encrypted payloads are invisible to it. Suricata or Zeek own that space. And finally, it's not magic. Scenarios can false positive, bouncers can fail silently, which is exactly why the rest of this course exists. So where does all this actually land in the real world? 3 archetypes. The solo self-hoster runs one VPS, one agent with its local API, one IP tables bouncer, and the community block list, and watches SSH attempts collapse by 95% inside a week. The startup or SMB scales that out. 5+ agents reporting to a central LAPI, Nginx, and Iptables bouncers, the console for visibility. One person now defends the whole fleet. Enterprise goes distributed. HA LAPI clusters, AppSec on HTTP traffic, SIEM integration alongside the existing stack. Find the row that matches your context. That's the shape your Lesson 12 deployment will take. Before we close, lock these 6 ideas in. 1. CrowdSec fuses IPS, IDS, and WF into a single daemon. 2. It judges behavior, not signatures, so novel attacks don't slip through. 3. Every scenario is a leaky bucket. Events drip in, overflow triggers a decision. 4. Local detection feeds a curated global block list, 95,000 servers strong. 5. Decisions move through triggered, active, expired, deleted. And 6. Never write parsers from scratch. The hub already has them. These 6 are the lens for everything in CSCLE output from Lesson 02 onward. And that's Lesson 01 in the bag. You can now explain what CrowdSec is, why behavior beats signatures, how the leaky bucket works, and why the hub matters. The 4 checkpoints we set out to clear. Next up, we stop talking and start installing. Lesson 02 is a 5-minute apt install, your first SSH brute force detection caught live, and your first CSSCLI decisions list. See you there.